To get ready for our bigger survey questions, we're going to start by looking at the cardinal number formula. So the cardinal number formula says the number of elements in A union B can be broken up into the number of elements in A plus the number of elements in B minus the elements that are in both A and B. So let's take an example and say, what if I told you there were 20 elements in A, 17 in B, and 8 that they had in common? We want to find the number of elements in A union B. So to do that, we're going to take the number of elements in A, which was 20, add it to the number of elements in B, which was 17, and then subtract anything that's already appeared there in both of them. So if I add 20 and 17, which gives me 37, and subtract 8, I get 29. To really help you visualize this, you can see I added a Venn diagram there too, just to say when we look at a Venn diagram, we would always start in the intersection, which would be our 8, and say that A has a total of 20. So since there's already 8 there, I would add 12 more, so now I have 20 elements in A. B has 17 elements, but I can see I already have 8 showing in B, so I would only have to add 9 more so that I have 17. Then you can see when you add 12, 8, and 9, you have 29 that appears in the union. So this just gives us a formula so that we can relate these numbers together. So let's look at another example. Say I told you I had 30 elements in A, 40 elements in B, and I know they share 20 elements in common, so let's find the number of elements that would be in the union. So once again, I'm using the cardinal number formula that says the number in the union is the number in the individual sets minus the intersection. So I'm going to put in here that I had 30 in A, 40 in B, minus 20 that they share. 30 and 40 gives me 70, minus 20 says I have 50 when I put the union together. Same thing, let's just do one more, and this time I've switched what we're going to solve for. So in the previous two, I solved for the number in the union. This time I'm going to solve for the number in the intersection, and I'll kind of sort of use the formula. We'll see how it goes. So let's start with, I told you there's 10 in A, there's 15 in B, and 21 in the union, so I want to find the number in the intersection. So what should generally pop into your head is let's add the 10 and the 15 to get 25. And immediately you should think, well, 25 is bigger than 21. That's great thinking, because that difference between the two, that 25 and 21 difference, is our solution. So the number in the intersection would be 4. It's whatever is just too much. That's what we want to look at. That's our overlap. All right, so here's 2 for you to try, which are both the situations we just covered. The first one you're going to solve for the union, the second one you'll solve for the intersection. And just give yourself a minute to pause the video, try these 2 out, and then come on back and we'll see how you did. Okay. So let's throw the answers. And the first one, to get A union B, I'm going to add the 22 and the 28, and then just remember to subtract the 16. So I added 22 and 28 to get 50. I subtracted 16, and now I'm at 34. Okay. In the second one, I had A was 40, B was 35, and the union is 60. So here I'm going to add the 40 and the 35 to get 75 and say, hey, that looks too big. So I'm going to subtract 75 and 60 to say they must be sharing 15. Okay. So why are we doing this? We're trying to get to application. So sometimes the application makes it more sense, and I have 2 separate videos on the application, one with 2 sets and then one with 3 sets. So let's start small and say, what about a survey of 100 parents? And it revealed 68 had sons and 72 had daughters. So I want to know how many parents had a son and a daughter. And obviously, there has to be some of both here. If there's 100 parents, right, I can't have 68 that have a son, 72 that have a daughter, because that adds up to too much already. I can say 68 and 72 is 140, so definitely there's some overlap here. And the overlap would be 40. 40 of them would have both a son and a daughter. Okay. So let's try it again. Let's say I had a survey of police officers that said 105 worked nights, 120 worked weekends, and 175 worked nights or weekends. So how many of them are doing both nights and weekends? So to get the answer, I'm going to add, what do I have? I have 105 and I have 120, which gives me 225. Well, that 225 is bigger than 175, which means let's subtract those, and it says 50. So it says 50 of our police officers that we surveyed are working both nights and weekends. Right, so here's one for you. It says a survey of college students found 380 were taking face-to-face classes, 250 were taking online classes, and 445, well, I can't say that, 445 were taking face-to-face or online classes. So can you figure out how many of the students were taking both face-to-face and online classes? Give yourself a second to try that one out. Think about what we've been doing with it. See if you can figure out how many were doing both. You can pause me if you need to. All right, so let's look at that answer. I'm going to take that 380 and the 250, add it together, so 630. Okay, once again, my number's too big. So I'm going to subtract 445 from 630. It says 185, and that's my intersection. So hopefully that helps you understand how the counting principle works, and we're going to look at it deeper in the next two videos.